Hi guys, today we're talking about key features of polynomials. So like super important pieces of polynomials that are going to be the same for a lot of them. So we can use like better vocabulary when we're talking about them. So if I have f of x and f of x is this, I know that it has an x plus 2 part, has an x plus 1 part, and an x minus 2 part. And I can see that there's x, x, and x. I know that this is going to be like x to the third. So remember we learned that it has that cubic shape from yesterday. So we see it actually right here. And so this is f of x. And there's some things that we can use to talk about it. So as you guys know, zeros, right? Zeros are the same as solutions. And you guys were remembering yesterday that they fall on the x-axis. So it's where the line touches the x-axis. So in this case, we would have like right here, and right there. Right, solutions anywhere where it crosses the x-axis. So when we write them as a coordinate point, so I could say like -2, 0, -1, 0, and 2, 0. We can see them on the graph right here. I'm going to call this a 0. For these, it's really easy to see that they're like right on the line, so they're easy to do. Later on, we're going to check out how to do them on the calculator so we can get a more exact answer. So for y-intercepts, it's going to be where the line crosses the y-axis. So it's going to be this point here. So this point here, we're also going to write it as a coordinate point. So that'd be 0, -4. And I'm just going to label it on my graph, y-intercept. Yeah, so those are like pretty standard. We've seen those in the past. This is where it's going to get like a little bit different here for these ones. So we have turning points, and you can kind of imagine from that like it's where the graph turns. And so if we're dealing with turning points, our turning points are also called, like their official name is local minimums or maximums. And what that means is that they're not like the absolute maximum. So for example, this is what's called a local maximum. And it means like near to the other points around it, it's the highest point. So it's not necessarily the highest point because these points are definitely higher than it, but it is the highest point within this section of the graph. And so we can kind of estimate that as well. We're going to find out how to find them exactly. But we would say the maximum is maybe -1.5, 1-ish. So we'll put that one there. And then we would look for a place where the graph goes down and then comes back up. And that would be right here. And this is what we would call a local minimum. And that's because it's not the lowest point overall, right? These points would be lower, but it is the lowest part within this section. And so we want to talk about it. It's called a local minimum. So I would say this minimum is about 1, -6. Right? So approximately, right? It's a little bit off. So those are my maximums, minimums, y-intercepts, and zeros. We've dealt with all of those things before in terms of like just regular maximums and minimums with our quadratics. But the last piece is end behavior, which we started to talk about yesterday. And end behavior is the direction that it goes. Whoa, sorry, y'all. Is the direction that it goes once it's like ending, once it's done all this like up and down business. So what this kind of funky thing here with the infinity says is as x goes to infinity, y goes to, or f of x goes to something. So basically as x is traveling in the positive direction, so as we're going to the right on x, the question's asking where's the graph going? And as we go to the right, we can see that the graph is going up. And so we would say that this is going to positive infinity. Say that that's the up direction. we're also going to go the other direction. So this next one says as x goes to negative infinity, so negative infinity is over here, as x travels in this direction. It's asking what the graph is, and we see that the graph is headed down. And so we would say that it's going in the negative infinity direction. So when we write this one, we mean as the graph goes to the left, and we're saying that it's going down. So you're always going to write these like stems. You're always going to write the x goes to infinity as f of x goes to, and then you just fill in this part here. So again, you're just going to write this part, always, 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 and then you fill in something for that based on the graph. Okay, so that's our basic lesson for today. If you look on the inside of this thing, you're going to see the directions. So you guys should grab a calculator. You're going to plug this guy into your yellow calculator. You're going to sketch it, and we're going to plot the zeros. But we're going to use these directions because today we're dealing with decimals. And we want to use the decimals, the like exact decimals, to find what the exact zeros are. And then we're going to do the exact same thing for maximums and minimums. So we want to make sure that we are also using decimals on these. You have all the directions. The directions are like step by step right here. But if you also want help, there's a video on Canvas. It's just like a dude that helps you do it right there on the TI-84. So thanks, y'all. Talk to you soon. Bye.